Hello, everybody. This is the first, yeah, thanks for telling me to record. I just did a little bit of review, but we didn't miss anything. This is the fifth class on derivatives, so I'll call it derivative 5 when I put it on YouTube. And we're going to be covering a couple different topics today. The first one is implicit differentiation, which is just a slightly different way of getting derivatives when we have a y term. The next thing we're going to do is higher derivatives, which just means getting the derivative of the function more than once. So we can get the first derivative, and then the second derivative, third derivative, fourth derivative. Very straightforward, actually. And then hopefully we'll have time, I think we will, we'll start doing the tangent equation and the normal equation. So I guess that's 4 topics, but we've actually done the tangent equation before. So more like 2 big new topics. So let's get started. Just as a reminder, the assignment's on Wednesday, the test is on Sunday, and the final exam, or it's not really a final exam, it's a final test, is going to be next Saturday, June 20th at 8 o'clock. All right, so I'm going to erase the extra stuff there. You can look back on it if you need to. I'll try to post all those dates on YouTube, or sorry, on D2L, and the final is on all units. But don't worry about that for now. Let's worry about what we have to talk about today. So first things first. Implicit differentiation. Well, like I mentioned, implicit means that we're not able to solve for y explicitly. And what that means is normally we have y equals. In this case, we can't get y equals form. So normally it's like y equals 5x or something. In this case, the x is all mixed up. Look at this. We have y to the power of 5. We have y squared. We cannot solve this for y because we don't know how to get it on its own, isolated on the side of the page. And so when we have these cases, we need to do what's called an implicit differentiation. Or more specifically, normally we're given things like this. You know, no problem. But today we're going to have things that are like this. And once again, in this case, there's only y on the left side. In this case, there's y in more than one place. That's a problem. We just go ahead and do what's called implicit differentiation. One thing to mention, and I don't know if you'll understand this or not, but I'll say it anyway. It says such a function, in this case, y, is called defined implicitly. It's a function of x. That y is actually a function of x, which means we need to consider the chain rule when we do it. It's just called an implicit function, but let me jump ahead to the point. The derivative, it's okay, Mohammed. The derivative of y with respect to x is dy or y prime. Let's do the first example so you can see what I mean. I'm going to rewrite the example over here on the side. And we'll come back to the notes, okay? We'll come back there. So first things first, we have a y term. We're going to treat this what's called implicit because it's like in the middle. It's all mixed up. It's not solved for y. Let's just treat it like we normally would. What's the derivative of x? The derivative of x is 1. You should know that from that by now. It's because there's a 1x, and so we get the 1 out of it. The next one, what's the derivative of y? Well, this one's a little weird. Let me show you something. If it was x, the derivative would be 1. Or let me make it more clear. The derivative of x gives 1. The derivative of y also gives 1, but because it's a y, we need to do something different. We call it y, we add a y prime term. That's our big difference today. I'm not going to over-explain that. You'll just see as it comes out that that's what we're going to keep getting. Y prime. Can't we make x with 2? Yes. There's 2 ways to do this, Muhammad. I'll show you. So first of all, that's 0. I'll move this down. That's a side note. That's just a little note. We'll come back to that. And bring this to the other side, and we'll solve for our y prime. Our derivative equals -1. So the first example is the most simple possible example I could give you. to show you how it's done when it's not solved for y already. Now, Mohammed made a really good point. There's another way to do this. What if you were given this and you said, hey, the y's in the middle, why not move the x over to the other side? Well, you can. You can say this. You can say 2 minus x. So I'll say this is another method we could do this. Y is 2 minus x, and get the derivative. That means that y prime is 0. I'll write the 0. This will be the only time really that I write the 0. Minus 1, or y prime equals negative 1. And if you're paying close attention, you'll see that these are the same. So Mohammed made a really good point. If you can, solve for y. It's going to be easier. You don't have to worry about these weird things in the middle. If you don't have y solved for and you can't solve for it, you don't have a choice. You have to do what's called implicit. Let me show you some other examples of what's going to happen in a second. This is all a side note. If you had the derivative of 2x, can you tell me what that would be? What's the derivative of 2x? Really easy. 2. The derivative of 2y is also 2, but we actually need to do the chain rule. We do the derivative of the outside and then the derivative of the inside. It pops out a y prime. So what I'm trying to remind you is that anytime you get the derivative of y, you actually have to get a y prime term as well that comes out of it. In many math courses, higher level, it actually mentions this as well. It says it's 2 times x prime, but x prime is 1, so it becomes 2. But I'm not going to include that. That's just going to confuse you even more. So that's one example. I'll do one more example and then we'll move on. What if you had 4x cubed? What would be the derivative of that? When you bring the 2 down, multiply, it becomes 12x to the power of 2. Hopefully we're all following. If this was y, if it was 4y cubed, the 3 comes down, becomes 12y, and then 3. I think of this as the power comes down, keep the inside the same, which is the y, don't touch it, then get the derivative of the inside. It's actually a chain rule. We get the derivative of this, which is our y prime. So our final answer, when we have y's, it always kind of spits out a y prime term, and that's what it looks like when we have derivatives of implicit functions. So with that in mind, we can go ahead and we can actually do the questions in the examples with very little difficulty. I guess the one last thing I'll say is that y prime, another way of writing it, which I've said before, is also dy by dx. It means the derivative of the function y with respect to x. X is our special variable here. Okay, let's try some examples. Let's try this example. And if you're just joining us, this is page 42. Let's see what we can do. First real example on the page. Is this, first of all, is this implicit? It says find dy by dx if this is 5. Yes, it is implicit. I know it's implicit because y is kind of in the middle of it. It's not solved for y. Sorry, my computer did something weird there. It's not already solved for y, and that means it's implicit. Quick question, could we solve it for y? I wouldn't write this down, please, but if you tried to solve for y, you would get this. When you try to get y, it would actually be plus or minus 5 minus 2x squared, and you'd end up being a more difficult question, and you would have to do it twice because you'd have to do the positive derivative and the negative derivative, and that is not worth it. It's much easier to do it all at once. So we're not, so Zara, you said move the x. That's what I did, but you see that it's a little bit complicated. So what we're going to do is do it implicitly right away. So what's the derivative of y squared? Well, it's the same as the derivative of x squared. So 2y, but it gives us this y prime term. So don't forget, it's not 2y, it's 2y, y prime. And the reason for that I'll write it to the side. You need to think of it like the chain rule. The 2 comes down, we reduce this by 1, and then we get the derivative of the inside. So it becomes 2y to the power of nothing, and then the derivative of the inside, which in this case is the derivative of whatever this function y is. We don't know. It's y prime. So you said, can you keep it y squared? No, you can't. For the reasons that I said earlier, we're not allowed to keep it. We have to do it this way. It won't work out properly if we don't. Okay, now this is by far the most important part of the question. The rest of the question follows. Derivative of 2x squared is 4x. Derivative of 5 is 0. Now we solve this for y prime. So the first step is just to get the derivative. Second step, so I'll just say the first step is get the derivative. The second step here really is to solve for y prime. So I'm going to do that. I'm going to bring that over to this side. I end up with 2y, y prime equals negative 4x. I'm going to divide both sides by 2y. I might as well keep highlighting. I've started, I might as well finish it. Cancel, cancel. So our final answer, y prime, is negative 2x over y. Okay. How's that so far? Easy peasy? It's okay if it's not easy peasy, I don't mind. I can also take not easy peasy, and I can go back through any of it. Kind of don't understand how we got the y prime. Okay, so when you say you don't understand how you got the y prime, do you mean in the first step or in the last step? First step. Okay, well, the fastest way to know how to do this, and sort of the short way, is to compare it. So right now we've got y squared, and we need to get the derivative. I'm just going to leave that there. If it was x squared, that would be 2x. And technically speaking, think of it like the chain rule. You bring the 2 down, keep the inside the same, in this case the x, and then you'll get the derivative of the inside. What's the derivative of this? It would be 1. So we actually don't write it. If you do it with y, you end up with 2y. The derivative of the inside, because it's not an x, it's a y, we're not allowed to just delete it. It becomes y prime, and that's where it stays. So when you have y's, it pops out a y prime term. When you have an x, it does not pop out a special term. It just stays the way it is. Okay, so this is just a side note. And kind of like Ali said, if you see a few more examples, you see that every time I do the derivative of y, it's going to spit out a y prime term. And you'll actually notice this, even from the beginning we've been doing this. Notice this. We wanted the derivative of this. Well, what does y give us? It doesn't give us 1. It gives us y prime. So we've been seeing this all along. It's just been hiding in the background. So let's go ahead and do another example. If you need me to go back up, I will. Whoa, where did my notes go? Where did it throw me? Sorry, it threw me like 5 pages away. This computer is fighting with me today, as usual. Okay, find dy by dx. So that means find the derivative. You don't need to use the term dy by dx. You can use the word y prime. It's the same thing. So let's see. We need the derivative of 3y to the power of 4. If it was an x, this would be 12y to the power of 3. But it's not an x. It's a y. So it spits out this y prime term. Okay? If you're getting derivatives of y's, y here is actually a function of x. We just don't know what that function is. Could be x plus 1. We don't know. So we need to say, if it was a big old bracket, think of it like this. If we had 3 something to the power of 4, then the derivative would be 12 something to the power of 3 times the derivative of that something. It would still give the same structure. It's tricky, but you'll get used to it. Plus, we have a problem. We have a big problem. And many students don't catch it. This is our problem. I'm going to make some space. Does anyone know why it's a problem? I'll tell you right now, it's not 1 times 2y times y prime. That's not the answer. Yeah, Zada got it. It's the product rule. And the reason it's the product rule is because we have an x and a y touching. They are 2 different functions. They're 2 different variables, 2 different functions. If we have 2 different variables or functions touching, we have to use the product rule. It's extremely important. It's the whole point of this question, is to figure that out. So what's the derivative of the first one? First of all, let me write down the product rule here. You should have this memorized by now. FG. First, last prime. So the derivative of the first one is 1. Keep the second one the same, plus the first one, x, times the derivative of the second one, which is 2y times y prime. That's our product rule in the blue, except for the very end. Now I'm going to do the derivative of 2x cubed, which is 6x squared, minus 0, so I'm not going to write the 0, equals 0. Okay, before I move any further, I'll just highlight this. This goes to this. This goes to this. And this goes to this. So if you need to, if you watch this back later, you can pause the video and compare them. But I'm pretty sure I haven't made a mistake yet. How do we feel about that before I move on? Derivative of the first one, second one, plus first one, derivative of the second one. Good, good, good. What we're going to do now is solve for y prime. So I need to move any term that's not touching the y prime, I need to move over. So it's gonna get a little bit messy, but try to bear with me. I'm gonna move this term over, and I'm gonna move this term over to the other side. That's because this term and this term don't have y prime. And I'm trying to solve for y prime. I'm gonna have to factor it out. So let's go one step further. 12y cubed times y prime plus, I'm going to multiply this out. That's 2xy y prime equals negative 6x squared minus y squared. Yes, Mohammed. You kind of did the power rule. Okay. I don't know how I'm going to know what you did. The xy squared. Do you mean you did like this? Sorry, for anyone watching the video, it's not going to make sense, but I'm just looking in the chat. So you put the 2 down. So you got it to be like 2xy. And then had a y prime in the end. Yeah, that is a total coincidence. That just happened to work. You got really lucky. If it was anything else, it would be totally different. So please don't do that. It was just chance. If you were to get a different number for any of this, it really wouldn't work out like that at all. Okay. And the thing is, one thing that you really miss doing that is that, yeah, sure, you got this term, yeah. The problem is you don't have this term. And if you don't have both, then you don't have the correct derivative. So the product rule spits out 2 terms, not 1. And Ibrahim, you said, please repeat for xy. So I'll go over here. Let's just say I had xy, and I wanted to get the derivative of this. Okay? First function, second function. Do the product rule. The derivative of the first one is 1 times the second one plus the first one times the derivative of the second one, y prime. So this would be our product rule. Okay, Ibrahim? So I did the same thing for our question here, except we had a square on the y. So if you had the square on the y, derivative of the first one, keep the second one the same, plus the first one, times the second one, which is 2y prime. So you'll notice that because I had the square, we get this term come out of it. Is that more clear? They're both the product rule. If you need me to go back to that, I will. Okay, so I'm going to finish this question. Once again, the whole point is to get the derivative. The derivative is y prime. So I actually need to solve for this. So we notice, hopefully you'll notice, that this and this actually are common factors. We're going to factor them outside. I'm going to factor this outside. What it leaves is 12y to the power of 3 plus 2xy equals what's on the right side. This looks like we still have a ton of work left to do, but we don't. We just need to divide both sides by this term. So we'll divide this. And on the right side, we're going to divide it as well. I probably should have left more space, but I've made my decision. I'm sticking to it. And this will be over. I'll put the answer over here. It cancels this, and we get our final answer. Y prime is negative 6x squared minus y squared all over 12y to the power of 3 plus 2xy. And you don't need to simplify that. It won't simplify nicely anyway. That's the answer just like it is. I'll write out a couple steps. First step I did was get the derivative. Second step I said move terms to the other side. The terms that don't have y in them. The third step is factor, and then I divided. So those are our basic steps. So on a scale of 1 to 10, 1 being terrible, 10 being I could probably teach this, what would be your feeling on this? I'll actually give this, I'll make this a chance to see who's actually in the chat too. So just give me a number, and when you give me your number, I'll mark down that you're still there, and I can feel like we're all alive out here, and my boss will be happy because I've made sure that my students are actually coming. Ibrahim, Ali, Zada's here, Kevin's still here, Hamza's still here with an exceptional 8.266. And that's about right. Looks like I'm missing Salah, Zayed. Can't win them all. So Salah and Zayed, hopefully you're still there. Please write something in the chat or I'll just send you out into the ether. Yep, we do need practice. So what we're going to do is do another one, and then we're going to do another one. Okay? Yeah, I know Ibrahim's here, but I don't know if Salah or Zayed is here. I know you're in the chat. Okay, let's keep going. Find the slope of the tangent line. Slope of the tangent line. Okay. We need the slope of the tangent line, and we need the point. So these steps are always the same for this. First things first, we're going to get derivative. Second thing, yep, there's product rule in this. Second step is always to sub in the given x. Give me the x value, which in this case is going to be x equals negative 3. I'll put that here. That'll be my x value. So Hamza, you said, can you try this question? Of course you can. I'm going to work on this question as well. And you can just ignore me if you want and check your work. But for some of you, I think you need the explanation still. So the first things first, I'm going to get the derivative. So let's do that. First step is the derivative. I'm going to write out the function right here so that I can look at it easier. I don't want you to have to look across the page. So I'm going to start the derivative now. Sorry, my notes just freaked out there. This is 6y squared, and it gives me a y prime value, the first derivative. So you got that, Mohammed. The next one, like you said, this is xy. It's going to be product rule. Even though it's not xy squared, it's xy, it's product rule. So I already did this for you, but I'll do it out again. It's the derivative of the first one times the second one. So I'll write out the 1, even though I don't need the 1, plus the first one, and then the derivative of the second is y prime. That's my product rule. The derivative of 1 is 0. The derivative of any constant is 0. So this is the whole thing. All right, this is my whole answer here. We can zoom in a little bit and clarify this. I'm going to do the same thing. I'm going to move my terms to the right side. Anything that doesn't already have y prime in it, I'm going to put it to the right side. So this term is going to go over there, and I'm going to factor. But I won't do too many steps in one because I don't want you to get lost. So the first term, 6y squared times y prime plus xy prime equals negative y. I just took the 1 times y, which is actually just y. I moved it to the right side. That became negative y. Now I'm going to factor out my y prime. When I factor out the y prime, it's just a variable. Like if you had a common x, I know you don't have trouble factoring it. So factor it like a regular variable. Pretend it was a regular letter, like an a. So this is y prime. It will get rid of this. So I end up with 6y squared. And then I factor this y prime out, which will essentially cancel it because I've divided it out, leaves the x, equals negative y. So when we finish, what we should get, because I'm dividing by this now, you don't need to show this pencil step. This is just for me to show you what I do. You can jump straight to this next step. It's going to be negative y over 6y squared plus x. And we're done. Well, we're not done. We've done the first step. There's 2 steps in this question. We've done the derivative. I'm seeing negative y over 6y squared plus xy. I'm seeing y over 6y squared plus x. I think, Mohammed, you made a small typo, but I think the basic the same. And yeah, Hamza, the slope of the tangent is indeed negative 1 over 3. And so I want to show you first, before I do anything else, that I've done the same steps. So the first step here is the derivative. The second step here, I'm moving the terms to the other side. 3, I'm factoring and dividing. And the fourth step is, of course, my answer. Now I need to go and do my second step. My second step is what I said on the left side of the page here, sub in my x. The problem is, actually, I don't need to sub in just my x. I need to sub in x and y. And the reason for that is because in my question, I have x, sure, but I also have y's, which I kind of forgot about, actually, even though I just did this earlier today. So we have 2 values, x and y. Let me just see, before I go any further, I've got some questions. Ali, you said, why does the derivative cancel? I'm not sure what you mean, because I haven't canceled it. Oh, I see. This here, I didn't cancel. I just was trying to visually show that when I factor it outside, I factored it out. What's left is just what I haven't canceled. So I'm left with 6y squared, and I'm left with x. That's why I did that. I didn't actually cancel it. I was just trying to show you what's left. Okay? So sorry about that. It's not really canceled. Maybe I should remove that. The other question, third step, why did I cancel the y? Same thing, right? So Ibrahim, same answer. I didn't really cancel it. I regret writing that. So I won't, I'll erase it. It's not canceled, I just factored it out. Sorry about that. So what I was saying was I have my answer, I need to substitute in my numbers now. So y prime is, I'm looking at this, -1 over 6, 1 squared plus -3, which you could actually, you don't need a calculator to do this one. It's -1 over 6 minus 3, or in other words, -1 over 3. Kalas. So now in this question, we had kind of both strategies together. You compare it to the previous question, you should see that they followed the same steps. Derivative, move the terms over if they're not touching y prime, and then factor to get the common factor. When you divide that out, you should have y prime. So you've solved for the derivative. All right, so let me show you what we did. If you're still writing that, I'll keep it there for you. I just want to show you what this looks like. Yes, the way to confirm it actually is to use Desmos. And some students don't like to do this, but this is what you would have to do. It's kind of the only way. I would write the original function, 2y cubed plus xy plus 1 equals 0. So this is my function. All right, it's insane. What is that function? It's probably the craziest function I've ever seen. And then I'm going to put the point -3 and 1. I know, what is that function? I'm going to look at this. That's our point. So I've graphed it. It's this crazy function. I don't think I've ever seen a function that looked like that before. So that's our function. And I want the tangent line at that point. So when I make my tangent, I'll do a freehand version. I think my tangent line should look like that. That's my guess. When I type it, I should get something that's basically on that line. Oh, this is the slope of the tangent at that point. Well, actually, just by looking at this, I can see that I'm actually right. This is a harder one to confirm. I thought I was gonna get a different thing. -1, 3. Slope is -1 over 3. I actually thought I was going to graph the line. I didn't expect to just graph the slope. I was thinking something else in my head. So long story short, you can sort of confirm it. You can say, okay, it's a negative slope at that point, but it's going to be hard to confirm it any other way. You might just have to get the practice with it. I learned something today, though. I saw that this implicit function looks crazy. Like, what even is that? Where's that line going? How does that happen? What is it? Anyway, sorry, I'm nerding out over this. Let's just pretend that that's not there. Okay. Long story short, very difficult to check this answer. But we'll check the answers a little bit later. A slightly different question. So the next questions are higher derivatives. Do you want one more example of these implicit so you can make sure that you know what you're doing before we move on to the next topic? No? You got it? All right. In the next practice section, I won't do the practice then because you can have it to try later. But one of the extra practice that would be good to do, if you want the more practice later, you should always be doing the practice in the notes anyway. I skipped them. But would be on page 47, question, sorry, page 46, question 2. So if you want more practice, you know, before the assignment or something like that, you want to get a bit more practice on it. There's one question there, and of course there's other practice in the notes. I'm just going to go look for them. There's also tons of practice on D2L. I mean, let me just mention this because for somehow students are still asking me, you know, about extra practice. They don't understand this, they don't understand that. So much of what you need to know is in this D2L show. So just let me make a slight side note here because I'm getting weird questions. This isn't your course, but same structure. So if you go into content, if you ever want more practice, there's 2 ways to do it. 3 ways, actually. First of all your classes are here. So derivatives, and then I'll choose, you know, I've got Wednesday, Thursday, Sunday. So we're actually, oops, I just moved something around in my shell. Great, perfect. Anyway, I'll fix that later. On Sunday, we have implicit differentiation. It says need more help. If you want more help, you can go into this and there's the website for it. And even in there, there's extra practice problems with full solution. Okay, so they have all of this. You just go for the section that you want. It says, what's the answer for this? What's the answer for this? What's the answer for this? Oftentimes, they're slightly different questions to what we're doing in class. That's for a good reason. The other place, if you want more classic practice, you know, paper and pen type of stuff, you go into derivatives, and at the very bottom, I've got extra practice. So Unit 5 review with the answer key. And then if you want even more practice, I've got unit reviews on the side of the page. For every single unit, there's a review. So you just tap that, and then every unit has a review. So just in case you're wondering where to go get extra practice, you can go there. You can also go anywhere online, say product rule practice, and it'll give you a million different websites. The problem is sometimes they're harder than you would cover in this course. Okay, Khan Academy has some good lower level stuff, at least in the beginning of this. So you can try that too. Just a side note, I don't want you to feel like you are looking for practice. Okay. Let us continue, my friends. Higher derivatives. Higher derivatives is very simple. We may take the derivative of the derivative. So if you have y prime, that's the first derivative. If you want the second derivative, just get the derivative of y prime. So you can have y prime, you can have double prime, you can have y triple prime, y quadruple prime. You can have the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th derivative. You can get derivatives all day long. It's the same strategy. You just do it again and again. So the first one's called the first. The second one's called the second. As you go on, the group is called the higher derivatives. It's not harder. It's not harder. The reason it's not more difficult is because the more derivatives you get, the functions actually get easier. Quadratics turn into linears. Linears turn into constants. Constants turn into 0. So they actually get smaller as you go, not bigger. So don't freak out. The notation, first derivative, second derivative, 1 dash, 2 dash, triple prime, quadruple prime. That's not y to the power of 4. It's y with a bracket. That's a very common notation. You'll also see f prime, f double prime, f triple prime, f4, so fourth derivative. So I want you to feel better about this. I don't want you to freak out. So let's actually do a bit of practice. And you can see that these aren't as scary as they might sound. Okay? So first of all, find the higher derivatives for this function. And my tip to you is go, keep doing it. Keep doing it until we get 0. You'll know when we get there. This isn't an implicit question, so it's quite simple. First derivative is 15 x squared minus 2. Second derivative, you get the derivative of that answer. imagine people who miss these classes. Well, some students miss it and they find a way to make up for it. But I really wish more people would come to these classes so that I can help. I think a lot of students are getting tutors or they're stealing other people's answers. They're not getting any smarter. They're just getting more clever about how to cheat. But that just makes you stupider. Cheating is not your brain, it's someone else's brain. Anyway, I don't want to get into that. If you're going to cheat, you're going to cheat, I guess. But you don't get any smarter because of it. No one's going to pay you to cheat. People want to pay you to do a good job. So this is where you go to get better at things. Okay, so we have 30x. 2 is, of course, goes to 0. What's the third derivative? 30. What's the fourth derivative? I'm going to put a bracket with a 4. It's 0. And now I finished. How do I know I'm done? Well, I can't go any further. So like you said, Ibrahim, you said 4. Ali, you confirmed it. If I went any further, say y equals 5, well, I'm just getting the derivative of 0. What's the slope of nothing? Nothing. What's the slope of nothing? I mean, you could do it all day, but why? Why? Why would you bother? Hi. So when it says higher derivatives, it just means get y prime, get double prime, get triple prime, blah, 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 blah. And for 5, you say it'll still be 0 if you do for 5 also. Yeah, I think you're saying the same thing that I said right here. And it's 0 all the way down. As soon as you get a function of 0, it's the slope of nothing. Okay, so Zada, hopefully you feel better. You're not so scared of this. It's not as bad as it looks. There are slightly harder questions. We're going to do one now, but I wouldn't call them difficult. They just are slightly longer. So let's look at this. Find the higher derivatives of this function. And as you will see it on your page, it says simplify the derivative. I think that there's a typo because that's a really not a smart method. What it's trying to say is simplify the function first. So take your function, and instead of doing the derivative, you'd need to do product rule. Simplify it, expand it. So what this is, it's x. I'll just write it below, actually. F of x is x. I'm going to expand the brackets. You can do that on your own time. Square the first one, multiply the first and the second one, and double it. And then square the last one. And now, expand through by that x. It becomes x to the power of 5 minus x, 2x to the power of 3 plus 1. Plus x. So now we have a function that is very easy to get the derivative of. And as a little trick, I already know how many we're going to need. So listen to this. This is a little quick trick. If the highest power is 3, we're going to have 4 derivatives. It's always the highest power plus 1. So in this case, if the higher power is 5, we're going to have 6 derivatives in that space. You should get 6 derivatives before we end up getting 0. Okay, so that's a little way of knowing how far you're supposed to get. Let's go ahead and work this out. So first derivative, this is the easy part. If you know your derivatives, it's simple, easy peasy. 5x to the power 4. I'm actually not going to talk through this. You try it yourself and see if you match. I got my 0. Let's see, so Hamza, you said the first one was too long. Maybe you did the product rule first. And Ali, you said you still have to show the workings. Yes, definitely. We're not looking for the final derivative, of course we know it's going to be 0, we need to find all of the higher derivatives. So we need to find the first one, second one, third one, fourth one, fifth one until the end. Yeah, Ali, it's not asking how many derivatives. It's asking what are the derivatives. And that's a totally different question. Knowing it's going to be 6 is just a way of checking your answer. So I look back on this and I'm like, hey, I know when I started I was going to get 6 because it's that power tells me so. But I didn't know what they were going to be. I just knew how much work I had to expect. Okay, so Hamza, you see your mistake? Let me make a side note as to what would happen if you didn't do what I just did. Make a slight little change here. If you did the first derivative without expanding first, you would use the product rule, okay? So you would do first one, second one. So the derivative of the first one is 1. Keep the second one the same. Plus the first one. And then the derivative of the second one, bring the 2 down, keep the inside the same, get the derivative of the inside. You would have to keep simplifying that until we have a better answer. Because it says here, look, simplify the derivative. So we'd actually have to go further, and we'd have to multiply these out. I'm showing you this because some students actually prefer this, although I don't know why. You need to expand this one. Plus x times 2 times 2x is 4x squared times x squared minus 1. You'd have to go even further, multiplying through by the brackets here. And then you would actually get your first derivative, which is way easier if you expanded it first. Okay, so this would be our first derivative, which in my opinion, I would rather my method. I think you'll agree that if you followed my way, you get your answer a lot faster. The reason that you should know that you can do it my way is if you only see squares, it's very simple to expand squares. If it's a cubic or a power 4, it's not so simple. Okay, so before we go any further, can you just let me know if you have any issues with this so far? No issues from Ali, that's good to know. No issues from Zara. Oh, my back. I need to just go lie down somewhere. Not right now, but when I'm finished. Where'd my cat go? No, she's sleeping in the bed. Okay, let's continue. Let's do some more examples. I'll make it, shall I make it harder? No. I'm not going to make it harder. I'm just going to change it. Let's see. Evaluate the second derivative of this function for x equals -2. And I've put a hint there, change form first. What I mean by that is if you look at this function, you see that there's a quotient. Of course, there's a function on bottom. I don't want to use the quotient rule unless I have to. And I brought this up yesterday. Why use the quotient rule if you can do an easier way? So my trick is that if you see a constant on top, and you'll only notice these tricks as you do the practice, okay? This is why I'm bringing this up. If you see a constant on top, you can change the form of this. So I'm going to change the form. Change form to this. Y equals, keep the constant, bring the bottom up, 1 minus x, put the brackets around it, and make it to the power of -1. That's because, look, on bottom, technically this is a -1. So I've just took the whole bottom, I just put it on the top, because I know it's going to be easier. I know it's going to be easier, and you will see it why soon. And made it a function that I can use the chain rule on. So I'm saying, look, there's no product here really. There's no quotient. Now I'm just going to say, now we can use the chain rule. And the chain rule is much easier because it's y equals 2x to the negative 1 form. If it's in that form, I just bring the negative 1 down, multiply it, all that stuff. So let's actually start. I'll show you what I'm meaning here. First things first. What's our function? I'm just rewriting it. Everything I write in pencil, I call it pencil, it's like fake pencil, is things that I'm trying to help you understand. You would never need to write it on a test. I think you know that by now, but just as a reminder. So let's get our derivative. How do we do it? Just as a reminder of the chain rule, take the power, multiply it by the first one. That's a 2. Keep the inside the same and reduce this by 1. Negative 2 minus 1, yeah? Negative 2 minus 1 is negative 2. Sorry, negative 1 minus 1 is negative 2. Then we take the inside, get the derivative of the inside. So the short way, derivative of the outside, keep the inside, derivative of the inside. Negative 1. Negative 1. And then you're saying Ibrahim, negative 1 times 2 is 2. Yes, exactly. So this 2 multiplies by this negative 1, and we get our negative 2. Sorry, my computer's going slow. So that's our first step. This is our first derivative. We know that because it's called y prime. But just in case you're lost, that's our first derivative. Now we need to do our second derivative. So Mohammed, you said y prime or y double prime. Yeah, I've only done one derivative, and it's very important that you notice why it's only the first derivative. The very first step was just a change of form. I just made it look different. I did not use a derivative rule. So I changed the way it looked to make it easier for me. I got it into power form. Then I did my chain rule. Once I've done the chain rule, that's my derivative. Now I'm going to do my second derivative. So the second derivative is easy. It's the exact same process. So I bring the negative 2 down, multiply, becomes positive 4. Wait. I forgot my negative in front. And then it would be a positive. I think this is what you were trying to tell me, Ibrahim, yeah? Yeah. Sorry, I'm a bit dense sometimes. I thought you were telling me something. Oh, I just missed it. So just so everyone knows, I made a little mistake there, so make sure that you change it. So negative 1 times 2 is, of course, negative 2. My bad. And then you should get a positive 2 at the end. That means that when we do our derivative, we get negative 4. 1 minus x. What's negative 2 minus 1 again? Well, it's negative 3. And then the derivative of the inside is negative 1. I'm going to simplify this. 4, 1 minus x, negative 3. So now that's our second derivative. It says evaluate the second derivative. Evaluate means substitute in the x value. That's what evaluate means. So we need to take our answer here and substitute x. Evaluate for x equals negative 2. So y double prime, the second derivative, also known as the concavity, second derivative of the the second derivative when x equals negative 2 is, it's one of those days, it just seems to get longer and longer instead of shorter and shorter. Should be positive 4 over 27. I made it. I made it. If you want to give the decimal, some students like to give the decimal to think about what the slope is. It means that the slope at that point is very gentle up. It's not zero, it's not negative, it's just slightly upward at that point. I want to make a slight note. Some students like to write this differently. I'm just going to write an or. Well, actually, before I write anything else, this is your time to ask me if you have any questions on what I just did. Any questions at all? Why did we do y double prime? I did y double prime because it said evaluate the second derivative. And the second derivative is y double prime. Any other questions? So there's one note I want to make, and that's, what if you had a slightly different form? So some students, for whatever reason, they have different ways they like to see things. They would rewrite the second derivative as this. It's the exact same thing. You can still put in your x equals -2 qubit. You would see that you still get 4/27. So just as a side note, I don't know, this is a little bit ugly, but hopefully I haven't made too much of a mess of it. Okay, on a scale of 1 to 10, how do we feel about that one? We're going to do one more of these, just one. 8. 8 is good. Feel good. Feel good, man. Better than 8.266. Maybe 8.3. We got a 10. Oh, now Ibrahim's 8.266. You just crack me up. You make quarantine bearable. Get some sort of crazy people in the chat to talk to every now and then. Okay, let's do another one. Of course, if you need to review this, just watch the video. That's what they're there for. Fresh start. Find y double prime for the implicit function defined by this. How do I know it's implicit? I know that there's a y in the middle, or in other words, it's not already solved for y equals. It's not solved for y. I guess I don't need to write the other stuff. It's not already solved for y. You could try to solve it for y, but you're going to make the question more difficult, so don't bother, okay? You want to find y double prime. So the first step, and this is a little bit of a tricky question, so try to put on your thinking caps now. First derivative is 4x, I'm looking at this, and I'm thinking about it, is 4x plus 6y, y prime, equals 0. All right, it's implicit, and so we need our y prime stuff to come out of this, right? Whenever you get a derivative of a y function, it gives us y prime. There is no product rule to worry about for this, so we're okay. I'm going to bring the 4x to the other side and divide. So we have 6y, y prime equals -4x. We'll divide both sides by 6y. Cancel, cancel. That means our derivative is, what's this? -2x over 3y. That's our first derivative. I feel like that was pretty painless. That wasn't a very difficult one. The problem is we need to do the second derivative. So if this is the first derivative, what do we notice about our answer? What form is it in? Is it a power form? Is it product form? Is it quotient form? Those are really only our three types. We got chain rule, there's no product, there's no composite functions here. So yeah, this is a quotient. So in order to get the second derivative, we need to use the quotient rule, which most of you, I hope, have memorized by now. We've used it enough times. but I'll write it out here anyway. We need to use the quotient rule, which I certainly hope you know what it is. It's still FG. It has a minus and a dash. That's our rule. We've used it many times. Looking at the chat, ribbing each other. Okay, let's use the quotient rule to get the second derivative. Y double prime is the derivative of the top, -2, times the bottom, 3y, minus the top, -2x. And the derivative of the bottom, 3, it would be 3 if this was 3x. Not 3x. 3y prime. Then we make a note. The derivative of 3x is 3. The derivative of 3y is 3y prime. So that's my quotient rule. All over the bottom squared, as per my rule. All over 3y, all squared. Before I go any further, I need to simplify this because it's not very nice the way it is. It's not going to be easy to finish the question if I don't simplify. So from here to here, I'm going to simplify. I'm doing -2 times 3, which is -6y, plus 6xy prime over, how do we do this now? Well, if you're very careful, you square everything inside, square the 3, square the y. We can only do this for what's called monomials. If the bracket has one term inside, it doesn't work for any other case. 9y squared. So students feel like they're done at this point, but we have one more step. Up until this point, how do we feel? Have I lost you yet? Geeg. Feeling geeg. Let me recap. Find y double prime. So we had our formula, our function. Get the first derivative. Now we're on the second derivative, which is the whole point of the question. And I've gotten to a point where I'm not done. And the problem is, because you might even not even know that we have a problem. The problem is, there's a y prime in my first derivative. I need this in terms of x and y only. I can't have a y prime inside. So what I need to do is go back up earlier in my question and substitute in this. You need to put that in just as it is, and we will be done. We'll simplify if we need to, but I'll just put it in. So y double prime is -6y, just copying, 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 ooh, y prime. Okay, now I've replaced it, and I divide by same thing as before. All the black is just copying. I've stolen it from earlier in the question. I put that over here. All right, I just put it in. Substitute, direct substitution. I'm going to do a very simple simplifying. I'll substitute in y prime. I'm just going to simplify and I'll be done. This is a longer question. This is a trickier one, but probably the hardest that I would ever ask you to be able to do. For this topic. Ta-da! Any questions? I feel like that's the classic teacher thing to say. Any questions? I could be teaching rocket science and you'd be like, but I like to give you a chance. This is as hard as the implicit functions get. So, Ibrahim, when you say repeat the last step, do you mean to get from here to here? Well, I'll go back one step. We got to the second derivative, and I saw that there was still a first derivative inside my second derivative. So I got to this purple point, and I said, well, I'll just substitute in this. When I did that, that's why I got the purple. The same thing. To simplify, I just did this, all right? So I'll write out on the side, 6x over 2x over 3y. I can see that this is 6 times negative 2 divided by 3. 6 times negative 2 divided by 3 is 12 over 3, or 4. So that's all I did for that question. Another way to think of it, multiply the tops, you get negative 12 x squared on top over 3y, and then you can cancel or simplify. That gives a 4 on top and a 1 on bottom. You see it now? Okay. Sorry, I need to stretch it. I'm going to move on because some of you are still pretty quiet, and I don't even know, like some students just peace out after a few minutes anyway, so I can't trust you anymore. But I'll do let's see if I can do a practice problem here. Let's do one practice problem of this topic, the second derivative stuff. There's something a little different that you haven't seen before. You can do this on your own time. You should try 2 for sure. Not now, but a little later. You're asking me to do 4. I can do 4 out, if that's what you really want. You want me to do question 4 right now? Yeah, there's one more point. There'll be one more point after this, even. One more topic. Sorry, 1 second. My mom calling. Sorry, Mom. I'll do 4. I'll do it quickly. Right now, we can see that this is chain rule. I can see it's chain rule because I have a function inside the other. So let's do this. K of p. So just treat your x's like, treat your p's like x's. So the first derivative of p is, bring the 4 down, keep the inside the same. So the inside stays the same. I'm going to rewrite the inside. To the power of 4. All right, I've rewritten the inside. I rewrote this as this. That's not new. We saw that before. Okay, and I kept the inside the same. Now I need to get the derivative of the inside. So what I need to do is look at all this and treat it like its own question. I need the derivative. So let's do that. One big bracket. What's the derivative of 3p squared? It's 6p. So I've done that piece. And then what's the derivative of this? So this is going to be product rule. So this is our product rule, and that's where I'm going to start right now. So the derivative of the first one, keep the second one the same, plus the first one, and the derivative of the second, which is 1/2, keep the inside the same, reduce the power by 1, and get the derivative of the inside. The power of 4 at the end should be 3. Yep, thank you. And that's how we do that. So let me try to clarify. That's a nice bonus question. If this is product rule, first one, derivative of the first, and the first, second, derivative of the second. This would be how you do this question. Notice that G prime, if you only had this question, the second function, in order to get G prime, is its own power rule or own chain rule. So if this is G, then G prime is this. Okay, so even though it's part of a bigger question, you still need to use the chain rule when we have these products or when we have these composite functions. Is that to your liking? Question's finished. Anyone still alive out there? Did I scare you away? You need to look at a cat? I can show you a cat if that's what you need. That's it. Yeah, I mean, you don't need to simplify. That would be a bonus question. If I gave a question like this, it would be a bonus. I hope you like math. Did you have fun doing the chain rule? I hope you had very much fun doing the chain rule. Hello. Okay, goodbye. Say bye. Say bye. Cat doesn't talk. She's fat though, isn't she? She's a fat cat. Oh, I guess I should probably spend more time with her. No, her cat's name is Ness, not Tom. Actually, her original name when I first got her was this, which is, as you know, I hope, it's Ness. And then I was like, maybe she should just be Ness. It's a lot easier to say. And then I was like, well, I like the character Ness from Earthbound, or from Smash Brothers. So I changed it to Ness. It's a whole thing. Did I throw the cat? No, there's a bed. There's a bed behind me. I didn't like throw her off a balcony or something. She's safe. She's fine. She's down here. Anyway, it's not animal abuse. It's just, we're training for the circus. All right. So let me do number 6, and we'll pretend that I didn't just launch a cat. I swear she's still down there. And she's fine. She's fine. There's a couple broken bones. Let's do this question. What's the second derivative? Y double prime. Or I guess in this case it's P double prime of this. So I hope that actually, no, this isn't the last point, Ibrahim. But our next topic is pretty short and simple. You can always catch up, just watch the video later if you want to. The second derivative of this function, what is the first thing that I should do? Well, I see that there's a constant on top. And if I see that there's a simple constant on top, it's probably going to be pretty easy to fix this. Yeah, see you, Ibrahim. Thanks for coming. The function can be rewritten. Keep the 2 where it is, bring the x cubed up and make it negative. That's much easier. Much, much easier. And then once we have that, we can easily get the second derivative. Okay? So I'm going to write out the function. P of x is just x minus 2, x to the power of negative 3. Let me do the first derivative. It's going to be very simple. Derivative of x is 1 plus 6 x to the power of negative 6. That's my first derivative. Once I have the first derivative, it's just as easy to get the second derivative. You do the derivative again. And it almost always gets more simple. Second derivative is 0, is the derivative of 1. Derivative of a constant is 0. And then 6 times negative 4, negative 24, x to the power of negative 5. That's my second derivative. Or in other words, p double prime is negative 24 can stay on top, and just bring the power back down, bring the x term back down, and change the sign of the exponent. We're not done, because the question actually says, what's the second derivative of the function at the point 4 and 127 over 32? We don't need to break our backs to do this. The steps are still the same. The first step is the derivative. The second step is, I'll just write the second step over here. The second step is to substitute in x equals 4. So the second derivative, also known as the concavity of the function, when p is 4, equals negative 24 over 4 to the power of 5. 4 to the power of 5 is 1024, and all this simplifies down to 3 over 128. That's the slope of our function, whatever the function is at that point. Sorry, it's not the slope, it's the second derivative, which is a little bit different. We'll get to that next unit. Making sense? First derivative, second derivative, and it says, what is the second derivative at the point? Well, we just put in what the information that we know. And we're finished. I'm going to introduce the next topic, and I'd say we'll finish early, maybe 10 after 5, 5:10. Do we need any more examples of this particular topic before I move on to the next one? Mohammed, I think you're one of the only people still breathing out there. I'm not entirely convinced that Zaid is still there. You still there, Zaid? Okay. I also don't know if Salah's there, but if you're there, you know, tell me you're alive. Okay, moving on. Applications of the derivative, tangents and normals. Well, spoiler alert, we've already done. Sorry, Zada, do you need me to go back? You understand you're writing notes? You don't need to type, it's okay. Oh, Zahid is your neighbor. Spoiler alert, we've done the tangent line. This is the tangent line. It's the line that touches our curve. If this is our curve, the line that touches that at one single point. And we've actually already gotten the equation of the tangent line. So I'll just review the steps. There's 3 basic steps to find the equation of the tangent line at the point. First step is get the derivative. The second step is evaluate the derivative. And sometimes we're given 2 different points, or sorry, 2 different pieces of information. You can either put in just the x value, or you can put in the x and the y value. And that is crazy, Hamza, that Zayed is your neighbor. Insanity, actually. It's different when it's instructors. The instructors here kind of all live in a similar spot because it's cheaper, it's easier for the college. But for students, what are the chances? There's millions of people here. Crazy. So when we have implicit functions, oftentimes we have 2. I'll actually color code those. Oftentimes we have 2 values when it's implicit. And then our third step is to use the slope-intercept form y equals mx plus b. So let's go and just do it. Find the equation of the tangent line of this parabola, x squared minus 1, at the point -2, X equals -2 and y equals 3. So let's just look at this. Our function, this is our function f of x equals x squared minus 1. This is our tangent line in pink, and it has the value -2 and 3. So we want to find out how to draw that line. And Zada, you say parabola again. Don't worry about all your parabola's rules. It is not the same thing. In fact, it's much easier. You don't even need to know what it looks like. Just get the derivative, put some points in, we'll be finished, okay? You don't need to worry about the stuff from unit 3. Apparently I can't remember from unit 3. Three-step process. Follow me along. First step, derivative. Get the derivative of the first function. Derivative of the function is 2x. You're welcome. Very, very simple. Second step, and I'm going by the list that I showed you earlier, is essentially trying to put in your given information. So in this case, sub in your x and y values. In this case, we only need to sub in x equals -2. So the derivative when x is -2 is -4. What does the derivative mean? I really hope you know what it means by now. The derivative means the slope. It's the slope of the tangent line or the gradient. Ali said gradient, same thing. Slope is gradient, is the steepness. So if y, when x equals -2, if y is -4, that means that m, our slope, is -4. This is the slope of the tangent line. Sorry, I have a visitor who wants to see me. He apparently just woke up. You say hi?
No.
No?
I could hear you.
You could hear me?
Yeah.
You wanted to come see me?
Yeah.
Is it everything you ever dreamed of?
Okay.
You want the blue? You want to help teach? Take the pen. Here, you can draw them some pictures. Oh, you want the green?
Not.
Purple? You can draw. There you go. Nice. Much easier. Much easier to understand. You want green too? Can I finish my class and then we can play? Broccoli?
Yeah.
Yeah, broccoli's green. Okay, you're gonna go with mommy for a little while, okay? Okay? Say bye-bye. There's people in there. Say bye-bye. Okay. Okay. That's my son. He probably is scribbling just as much as you guys are, trying not to pay attention to me. But yeah, that's my son. So let's finish. Let's finish this question. We have a line, or sorry, we have a curved line, parabola. We know the slope now at this point. That's the slope of this line. You go down 1, down 4 for every one you go over. It's the slope of the tangent line. It is not the tangent line. It is not the equation. What we're going to do here is use y equals mx plus b to find b. Use y equals mx plus b to find b. What does that mean? We've done it before. Well, let me show you. Y equals mx plus b. We actually know all the information except for b. The x value was given. The y value was given. Even m is given in its own way. We just solved for it. In other words, y prime is m if we solve for it. So we can find b. We just need to find this b value. So let's put in all of our numbers. What's y? It's 3, -4, -2, plus b. So that means 3 equals 8 plus b. I'll just write it out. That means b is negative 5. Once again, we're not looking for b, we're looking for the slope of the tangent line, but this will help us get it. This is our last step. So I'll say, write the equation. Y equals m x plus b, or minus 5 in this case. Sorry, I'm getting all shaky. So, despite the child interruption, it's not so bad, is it? Even the next topic is almost exactly the same. We'll see that this is m, this is b, just in case you're wondering where these came from. The rest stay the same. Easy peasy, easy peasy, easy peasy, easy peasy peasy, easy peasy, easy peasy. So let me show you it on Desmos, just real quick, so that you can see that I'm not lying to you. And this is a way to check your work. This is what I was thinking of earlier. Let's just very quickly graph it because I know we're running out of time. At least I want to end early so that you can have a little bit of a break. This is how you check your work. Put in the original function, x squared minus 1. That's what it looks like. Your point that it's asking for, it wants the tangent line at this point. So you see that little blue point that I just put in? You can see it come up and off now. Just tapping that on and off. That's the line that we need. We need a line that's tangent at that point. So it should look like this. So I'll do my best to make it freehand. That's bad. You get the idea. It should look kind of like that. I'm doing my best to do it freehand. It's very difficult to do it without a computer. So let's let the computer do it for us. We've already figured it out. Negative y equals negative 4x minus 5. There we go, much better than I could do. So we zoom in on this, on the blue point, and I can see that that is definitely a tangent line. It only touches at one point, and it's showing us the slope of the line. You can see, obviously, if I do this, it's definitely only touching at one point. I'm done. And what's the point? It's negative 2, 3. That's our tangent line. If our equation was even off by one number, it would look crazy. It would be like something like this, or it'd be like this, or it'd be like this. But it's perfect, so we're good. All right, let's do one more question. Maybe two more questions because these don't take that long. And then we'll be done for the day, okay? Find the equation of the tangent line. It's an ellipse at this point, and the equation was given like this. So we can see, hopefully you're getting better at this, figuring out what's what. We can see that this is implicit. So we're going to have these y prime terms in the middle of our question. Let's just pretend that we aren't scared of this new question now and go through our three-step process. First step, we need to get the derivative. So the derivative of this is 8x plus 9y squared. What's the derivative of that? Well, it looks like it would be 18y equals 0. Is that good? This is okay? Remember, the entire question is based on this first step. If I make a mistake in this first step, you cannot do the rest. We're solving for y prime. Where's y prime? Can't find it. I don't see it. If you get the derivative of y, you need to get a y prime term. So I did that mistake on purpose. So I want you to make sure that you know we need a y prime term to come out of this, or else the question just goes to nothing. We can't solve it. Okay, and now we're going to solve for that. So I'm going to bring the 8x over like I did before and divide by the 18. So I have 18y, y prime, equals negative 8x. Divided by 18y, divided by 18y. They cancel. Y prime is then, what's 8 over 18? Well, if you solve that out, you can simplify it to 4x over 9y. That's our first derivative. It says find the equation of the line tangent to the ellipse. So we don't need a second derivative. First derivative is fine. What am I going to do next? Well, this is the equation that gives me the slope. And so if I put in, my second step, I can substitute in two values, x equals 1 and y equals 2. Because you'll hopefully see that this is an implicit question. And I have y and x. So just be careful. X equals 1, y equals 2. What do we have? Y prime is -4, x equals 1, 9, y equals 2. That simplifies out to -2 over 9. That means, therefore, m is -2 over 9. That's what those two dots mean. It just means if this is true, then I know m. That's the slope of the line. So wherever that is, we don't have a picture, but the slope at that point is -2 over 9. That is not our final answer. So I'm seeing 2 over 9. Now I need to find b, is what Ali said earlier. Third step, I'm just going to write it as u's, y equals mx plus b. Same as before. I'm going to say y is mx plus b. What's my y value? My y value is 2. What's my m? My m is -2 over 9. My x is 1, and my b is not known. If you work that out, you just get this. Bring it to the other side. That's the same as 9 over 9 plus 2 over 9. Sorry, 18 over 18 plus 2 over 18, 20 over 9. You can just put it in our calculator. Am I done? No. I need to actually write my equation. mx plus b. mx plus b. Now I'm going to check my work. I'm going to keep this there. And I want to do the exact same thing I did before, but graph it so that we can check our work. So we'll get rid of this stuff. While you're working it out, it says it's an ellipse. Let's see if Desmos confirms. Plus 9y squared equals 40. Hey, cool, it's an ellipse. What are the chances? We know that anyway, it's got a squared term and a squared term. Easy peasy. What's our point? Our point is 1, 2. Okay, I've got a nice black dot there. So I need the tangent line to that point. And if I had to guess, if I didn't have a computer to do this for me, I would probably say it looks something like this. That's my best guess. I'm just using the zoom tool to do that for me. I need the equation of that line. So I'm going to put in the equation. It'll give me the slope at that point. Or in other words, sorry, it'll give me the tangent line. So this is the moment of truth. It should perfectly go to that point. -2 over 9, x plus 20 over 9. We are the champions, my friends. Dun, dun, we'll keep on fighting till the end. Okay. I got the tangent line like a boss. Okay, we all got the tangent line. This is everybody. Everybody worked on this. Look at our ellipse. Perfect. Nice tangent line. Right at that point, our answer is correct. Pretty easy, in my opinion. It's pretty easy. I'm not going to do the next question. I'm just going to introduce the next topic, and then we'll be done for the day. Okay, so just give me maybe 2 more minutes, 3 more minutes maximum, and we'll be done. So the normal line is exactly like the tangent line, but it's perpendicular. So instead of our tangent line going and touching the point, touching it once, what the tangent is, or sorry, what the normal line is it's perfectly perpendicular to the tangent line. It goes perfectly perpendicular to the curve at that point. It's a little harder to explain why it's useful, but yeah, it's just perpendicular to the tangent line. So if this is our tangent, then our normal is perfectly opposite. And it has useful applications in physics and engineering. I won't get into that right now. I'll just get the basics down so that I've introduced this and we can finish. So the normal line to a point on a graph is the line perpendicular to the tangent line at that point. And what you'll notice is that the process for doing this is exactly the same. Look, first step, find the derivative. Same. Second step, evaluate the derivative at that point. Same. Third step, find the negative reciprocal. That's new. Find the negative reciprocal of the slope of the tangent line. What that means is take the slope, make it negative, and flip it. So if the slope of the tangent line is 2, the slope of the normal line would be negative 1 over 2. That's what that means. Sorry, you said your ear, was there a problem with the sound? Yeah, that happens sometimes. Tell me if it happens again, because normally it doesn't happen, but if the internet is bad, it'll make a crazy noise. So sorry about that if you heard a bad noise. My last point, the last step of this is the same. So it's still a, oh God, Ali, can you still hear me? Are you still alive out there? You had full volume. Bad, sorry. Anyway, long story short, to get the equation of the normal line, it's the exact same process, we just do the negative reciprocal at the third step. And I'll stop it there. I don't want to do the example because I feel I'm getting a bit tired, so I'm just going to rush it. And I think we've covered enough for the day. I'll stop the recording here, and then we'll see you next time.